Make the ground shake.
Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Senior Engineer and Technical Partner Manager here at VMware. Today we have a session all about storage. We're going to be looking at Virtual SAN 6 and all the enhancements and technical updates that came out of Partner Exchange this year. And we're also going to have a chance to look at some technical considerations when we're designing and advising our customers how to implement and adopt Virtual SAN 6. We're also going to have the opportunity to look at an introduction to virtual volumes. Some of you may remember virtual volumes as being in beta and topic of a lot of conversation for the past couple of years. And now we're going to see it come to GA and start to wrap ourselves around the idea of where this fits inside of the storage ecosystem. So with that, let's go ahead and get started. One of the best and easiest places to start when we're talking about virtual SAN is to start with what's new. We've all been relatively familiar with it for about the past year, given the fact that, we saw it come out of beta. Everybody was so excited when, it was originally just thought to be 8 nodes inside of a cluster, and that was really going to change the world. And then we saw it GA to 32 to match what was happening inside of vSphere 5.5. And then with the release and announcement of vSphere 6, we're seeing it grow to up to 64 nodes in a cluster. And I think this is a really important distinction to remember when you're talking about VMware technology, is the fact that we're looking at the cluster, and that a cluster really isn't just a collection of machinery. A cluster is a cohesive unit that operates inside of the data center. At that cluster level, we're dealing with all of those cool kernel-based technologies that are so foundational and have transformed the data center that VMware lives in. Everything from high availability, DRS, fault tolerance, and also vSAN. So when we talk about scale, we're not just talking about more servers. We're talking about scaling out all of this functionality too, which I believe is a really important distinction for us to start with. If we look, we can see too that virtual SAN is growing up. No more is it just a niche workload type of player. It was very easy at the beginning to kind of dismiss virtual SAN as just for VDI or just for test and dev workloads. But now we're seeing that with the advent of all of the new adoptions of technologies, the ability to clone, the ability to create additional snapshots down at the storage level, things we'll talk about here in a few minutes, that we're seeing it grow up inside of this space all the way into business critical workload capabilities. So really the core message when we're talking about what's new with virtual SAN is in how it's grown. So what's changed to allow it to grow this way? Well, if we take a look here at what's grown and what's changed, we now have that support for business critical applications. We have increased density and increased scalability given all the stuff that's bubbled into vSAN from vSphere 6. And we also have a whole new tier of data services. As I had mentioned before, the ability to create snapshots and clones right down at the storage level, right alongside other highly performant storage systems that are available inside of the market. So when we look at what vSAN can do now, again, it's about how it's grown, how it's moved into deeper cycles of the customer's maturity trajectory. One key change inside of virtual SAN 6 is in the architectural availability. We now have two architectures available to us. We have our old familiar architecture, the hybrid architecture, wherein you would have a minimum of one solid-state disk and one spinning disk. And that would create your disk group. And then you could scale that up and scale that out as needed in order to build out your cluster. And for those of you who don't remember, the purpose of the solid-state disk inside of that hybrid group was to provide a read cache and a write buffer to everything else, which made virtual SAN perfect for things like VDI, cloud workloads, and it was also very quickly adopted for things like test and dev tier 2, tier 3 workloads very early on because everybody wanted to see that work. And so now we're seeing that beyond just the standard hybrid architecture, that we also have the ability to adopt an all-flash solid-state drive architecture. This means that all of that cool functionality that was up there inside of the solid-state drive tier is now being boiled down throughout the entire virtual SAN array. It also means that we're going to have greater density, increased scale, and a whole heck of a lot more IOPS. So let's go ahead and look at each one of these a little bit closer. The first is the hybrid architecture. And like I said, this is the architecture that we were always kind of familiar with and we've been dealing with for the past year or so. This is the one where you had at least one solid state and one spinning disk. Now, you could scale that up inside of those disk groups to have one solid state and up to 7 spinning disks. And that gave you a pretty good sized disk group. And then you could multiply that 5 more times inside of each host. You could then replicate that up to 32 hosts, now 64 with vSphere 6, and your IOPS would follow right along with it. Now we're seeing IOPS available at or around 40,000 IOPS per host. And it scales pretty straightforward. If you have a minimum of 3 hosts, which is the requirement for virtual SAN, then you're going to be looking at 120,000 IOPS inside of that vSAN cluster. If you scale greater, you'll get more IOPS. Add a 4th, you're at 160. Add a 5th, you're at 200. So this allows us a little more architectural freedom when we're talking about how we're going to align virtual SAN with the customer's needs and the overall workload. This also means that we can do things way beyond what is traditionally thought as capable. You know, I had an interesting call this past week and somebody said, you know, what would happen if the storage that was in the server was just way too big for vSAN to deal with? And so we started talking and we were wondering, you know, what are we talking about? You know, 6 terabyte, 8 terabyte, 10 terabyte drives, you know, that could possibly be that big. Well, after doing a little math, we were able to back into the idea that because of vSphere 6 and because of the functionality and capability that that's bringing to bear, that virtual SAN would theoretically be able to support up to 2.25 petabytes per individual host. Now, that would require some really significant storage, and that would also completely break hardware compatibility. But it's very exciting to think that the software-based technology is already there. It's already there waiting for us. All we have to do is align the hardware compatibility with it, and then we're going to really see a lot of change inside of the data center. So now, to take a look at the all-flash virtual SAN array. This is a really exciting idea because now, instead of the flash being there just for read cache and write buffer, now the cache becomes 100% write. So it's able to function expediently throughout the storage stack. Additionally, we're looking at ridiculously high IOPS, up to 100,000 IOPS per host. Take that same idea we had a moment ago inside of the hybrid array, looking at 40,000 IOPS per host. And now we take that, you know, by another 1.5 times, and we're seeing some really dramatic amounts of density and some tremendous scale possibilities. Now, is this to say that I think that we're going to be deploying virtual SAN all-flash arrays out inside of every mid-market customer? Probably not today, but it is exciting to think that this technology is going to become more and more pedestrian, and we're going to see greater and greater adoption. And what we will have the capacity to do is when we're inside of our clients' boardrooms and they're bringing up different workloads and they're talking about what they're going to do about storage and this workload or that, and how they're going to parse the storage off to make it most effective. And then we're dealing and working with the storage administrators and virtual administrators and getting everybody to create a more cohesive vision together. Then we're going to be able to include things like all-flash virtual SAN arrays in the discussion. Because now, between the hybrid and the all-flash, there really isn't much we can't answer with virtual SAN. Everything from those tier 2, tier 3 workloads, test and dev, through tier 1 and business critical workloads, everywhere from small, medium business, mid-market, and the highest levels of enterprise, are going to be able to adopt and take advantage of the technology that virtual SAN is bringing to the market. So there's always a lot of talk around virtual SAN, especially with the conversations of scale. And everybody's quick to latch on to the idea of 64 nodes in a cluster. And while this is pretty impressive, you know, we have to back up and say, you know, when exactly are we going to be deploying 64 node clusters of virtual SAN? Well, that might not necessarily happen today, but we are going to see it grow, and it definitely gives us some architectural freedom when we're talking about scale up versus scale out approaches, especially on the compute side. But there are a few other things that I think that, you know, have kind of flown under the radar with virtual SAN that I wanted to bring to light today. You know, one of them was the 62 terabyte VMDK. Now, this isn't to say we're going to go out and create monster machines right out of the gate, but I have been in a ton of situations where, you know, we might have been, you know, replicating a physical infrastructure into a virtual platform, or P2V, if you will. And the drives and what that workload was dependent on was maybe just a little bit too big for the current constraints. And so we're seeing these increases between vSphere 6 and vSAN, giving us greater capacity, not necessarily just to create monster VMs, but just to suit those machines that are just too big for what we were capable of doing before. This goes back to kind of, in my opinion, VMware's overarching message, which is leverage existing investments, extend the ecosystem, and to be able to integrate with everything else inside of the data center. And so if we talk about now being able to really faithfully and truthfully replicate what's going on out there inside of the physical world, in the virtual world, the ability to provide those 62 terabyte VMDKs is definitely going to help us get there. Additionally, we see now that we have up to 32 snapshots per virtual machine. And this kind of, raises an interesting point. Years back when I was a VM admin, we had a case wherein we were doing a ton of development. The developers were using snapshots pretty much the exact way you should use them. They were going in, creating code, running a snapshot, and then testing, going back, doing another snapshot, and progressing through. Now, because the depth of the snapshots were so deep, I walked in one day to find out that the original virtual machine could no longer be found because the snapshot tree had gotten so deep that the trail of breadcrumbs going into the forest just simply could not find the original virtual machine anymore. And that was obviously a real heartbreaking day. Now, fast forward to where we are today, we see that we have the capacity for up to 32 snapshots per virtual machine. This is an exciting idea because it once again underlines vSAN's capacity and vSphere's capacity to adapt to all new types of workloads inside of the virtual data center and with the brave new IT that's being pushed out. So now let's take a quick look at an interaction between Bob, we remember Bob, the IT admin, and Fred, the storage admin, and how the promise of virtual SAN starts to change the dynamic and the paradigm that they're living with. So now I'd like to take a look at a whiteboard that kind of outlines the current state of SAN inside of the data center, as well as the potential opportunities for convergence in the way we approach administration. See, regardless of who we're serving from a technical perspective, whether it's networking, storage, or compute, all administration serves one master at the end of the day, and that's the end user. And the end user is going to consume resources inside of our data center. And that's going to include compute, storage, and networking resources. We remember that on the compute administration side, we have our good friend Bob. And Bob has domain over the vSphere infrastructure. And Bob's been keeping that up to date, and that's been advancing very rapidly over the past few years. However, because of the silo approach that we have with administration, it's very bicameral. Bob is not always in tune with what's happening back on the storage side. In fact, if we look at the storage side, that's been changing dramatically. You've got the paradigms of old storage, where maybe you have different hardware vendors, some where there have been large purchase cycles, others where they've only purchased a small amount of storage, and maybe in some cases only purchased just flash storage from specific vendors. And then we've had newer adoptions where administrators has tried to start aggregating this storage and bring it all together and even integrate virtualized storage front ends to make sense out of all of the legacy stuff in the back. And where Bob was administrating everything on the front end, we had Fred administrating everything on the back end. This is great right up until the end user is really no longer a user. Maybe that end user, instead of just requesting machines, is an entire department or an entire corporate initiative requesting whole new sets of deployments and whole new types of scale. Now, instead of just dealing with piecemeal, one machine at a time as needed, we're now seeing cloud scale grow that's requiring us to deal with multi-machine provisioning, tens, maybe even thousands of machines at any given time. This means that the interaction between Bob and Fred is changing. It's no longer enough to have this bottom-up approach where you create and you consume and then you rinse and repeat. This now has to be dynamic. It has to be based upon policy, who this end user is. And it has to be able to change rapidly at the speed of business. So this is where the promise and the ideas of virtual SAN and virtual volumes help us align. Virtual volumes now allows us integration into the physical storage realm, the physical storage array, so that we can offload some of the virtualization tasks, like all of this cloning, all of these snapshots, all of this deduplication that needs to happen, and we can offload it down to the storage that there's been so much investment in. Additionally, rather than just always consuming physical storage, we can also leverage virtual SAN inside of the compute and direct attached storage to allow us other workload functionalities to attach to. This means that we're able to scale efficiently, and we're able to do so while still adhering to this idea of convergence in administration. It really is a brave new IT that we're headed toward, and one that's got to adapt very quickly to the ever-changing needs of business. And these are the promises that we're seeing by allowing Bob and Fred to work together as converged administrators, as opposed to just living in individual silos and consistently taking a bottom-up approach to the infrastructure. So now that we see the interaction that has changed between Bob and Fred and the opportunity for excellence that is there for both of them, let's take a look at what this means to the overarching paradigm for storage inside of the data center. So if we see today, we've got a very bottom-up type of model. You have to go in and predefine your storage, pre-allocate storage bins, LUNs, expose those bins, and then pick the right ones, attach them to the right storage and the right application workload, and then consume until it's all used up. Once it's used up, go back and do it again. This leads to a lot of data migration, wasted resources because we might not use every bin the same way the same time. And we can also grossly over-provision. After all, it's better safe than sorry. Virtual SAN takes a dramatically different approach. In fact, we reverse the entire script and say instead of having a bottom-up approach to storage, we're taking a top-down approach to storage. By utilizing virtual SAN, we're defining the storage policy, then applying the policy at the creation of the VM. This means that we're going to have no over-provisioning. We're all going to be consuming out of one big pool without the need for bins and LUNs. It also means that it's very easy for us to change and adapt as we grow. This is a dramatically different concept and probably one that is going to be a little bit scary for a lot of folks. But when we look at the adoption and look at the capabilities for what vSAN is able to do, I think that it, again, underlines its readiness for business critical applications, and it allows us to position virtual SAN in all the more different type of solutions. Another cool new feature inside of virtual SAN, as far as highlights, is the use of the vSAN sparse disk. And to kind of highlight this idea, effectively what it means is we can take the cloning procedure away from the virtualization stack and bring it down to the storage level. Meaning that vSAN now is capable of doing snapshots and clones the same way that industry-leading storage arrays are. Once again, just showing where virtual SAN is growing and has grown in its capacity to meet customers' maturity. We also see virtual SAN now having the capacity to support fault domains. The basic principle is this. If you go in and you set up virtual SAN, it's one thing to set it up inside of one cluster in one rack in one data center. However, now you could set up virtual SAN spanning racks. And this allows, and we're able to create these virtual volumes down to the storage array. So every time you have operations and automation to give us clearer insight and more control over how we're provisioning storage in an on-demand cloud environment. This all ties back together, again, to this bigger picture, that it's not just about storage on the bottom and compute on the top. We're integrating all of these components together to create a more holistic ecosystem to support the brave new IT that we're headed toward. I want to thank you for joining today. I appreciate your time and hope you found value in these sessions. Please follow me online and be sure to register for additional sessions as they become available. I do appreciate your time today, and as always, this material will be available online for you to use and to be able to leverage with your customers in individual segments, as well as the slides that were used today being available for you to utilize within your own presentations. Thank you so much. Hope you have a fantastic day, and I look forward to talking to you again very soon.
Make the ground shake.